मेरे चैनल हिरानी स्टूडियो को सब्सक्राइब करें और घंटी के आइकन को दबाएं ताकि आने वाले वीडियो की जानकारी प्राप्त हो।
Hello everyone and good morning and welcome to this webinar on electrical safety testing, a complete overview part 2. This is the second part to the webinar that that some of you attended last time, which was the complete overview part 1 presented by Nick Pietrowski. Today we're gonna continue with that and further enhance our knowledge on electrical safety testing. My name is Syed Abidi and I will be presenting this webinar today. I'm the applications engineer here at Associated Research. Before we get into the meat of the webinar, a few quick notes for you guys. We do have a Q&A utility to ask any questions concerning the material being presented, and any questions related to the running of the meeting, with issues with audio or video, can be addressed to our host, Jim Kennedy, through our chat line. Also know that this webinar is being recorded and will be available to view usually within a day on our website. If you have any issues, again with the audio or video, and if you need a copy of the presentation, please feel free to contact Jim Kennedy via our chat line, and feel free to email Jim at jimk@asresearch.com, and he would send you a copy of this presentation. Okay, I guess we have enough people on board to go ahead and begin with our with today's webinar. Now, before we get into the material of this webinar, I'd like to just do a quick recap of what Nick went over in part 1 of this electrical safety testing webinar. Electrical safety testing, the definition of safety, and some electrical shock hazards and examples were covered in the previous webinar. Some examples of safe and unsafe test methods and examples were covered, and also you guys were presented with some training resources to help you further understand electrical safety testing and requirements. So this is what was all covered, and again, for those of you who were not able to attend the previous webinar, this was recorded and it is available to view on our website. Okay, so today we will be covering basically some most common electrical safety tests. We're going to be going over each of those tests, and then we're going to understand where and when are these tests required. We're going to touch some examples from the standards. Next, we're going to get into basically give you some tips and tricks to find the right testing device for your testing needs. We're going to give you examples, and next we're going to be giving you some tips and tricks on what not to do when testing, so that you better understand electrical safety testing and things that you're not supposed to do, things that can be a shock hazard. And then we'll leave the forum open for questions and answers. And while I'm presenting, feel free to use the Q&A facility, our chat line, to ask any questions on the materials being presented. Okay, now before we get into the common electrical safety test, the question is, why do we need to test? Well, as we all know, safety agencies have implemented and enforced electrical safety testing for one main reason, which is to protect consumers from potentially fatal electric shock. Most injuries and electrocutions are caused by either electrical products with faulty insulation or a product with a defeated safety grounding system. The insulation in question is used to basically separate the power line circuit from low voltage circuits, isolated power supplies, the chassis, or the case of the product. This insulation basically prevents current from an ordinary household outlet or any power source, which is almost an unlimited power source, from becoming hazardous by finding a ground path with something that is not meant to be a ground path. And for that very reason, the electrical safety test that we're going to be covering today, performing these tests will verify and ensure that a device or a product being tested has a proper safety ground and proper and strong enough insulation to bear any leakage currents or faults. We also, from our last webinar, remember that the products are classified in electrical products have been basically broken down into two categories for safety testing, Class 1 and Class 2. Once again, this is a sort of a review from our previous webinar, but it's important to know before we get into the electrical safety tests. A Class 1 product is basically terminated in a three-pronged line cord, specifically consisting of a hot and a neutral input and an earth-ground connection to the chassis. Whereas, if you recall, Class 2 products, also known as double insulated products, have no earth-ground connection to chassis, since the chassis itself is usually made of some insulating material such as plastic, etc. So yeah, here's a list of the most common electrical safety tests that Associated Research products testers are able to perform. And starting with the ground continuity test, which is probably the most simplest of all tests. Next, the ground bond test, the dielectric withstand test, also known as the high-pot test, the insulation resistance test, and finally the touch current test, more commonly known as line leakage test. And before we get into details of each of these tests, electrical safety tests are broken down into two separate groups: design or type tests and production line or routine tests. Type tests or design tests are usually performed to detect product flaws during the design stage of an electrical product. And these are conducted at an engineering level. These are conducted on samples of a product, usually conducted by the manufacturer and or the safety agency. The object is to detect product flaws during the design stage of an electrical product. So and also to determine if a product as designed and manufactured meets the requirement of the standard. And as we all know, safety standards are designed to ensure product safety by governing agencies like UL, TUV, IEC. And also the type tests are more rigorous than production line tests. Routine tests. Routine tests are performed on each product at the end of production line. So basically, routine tests are also usually required to be performed on 100% of the products leaving a facility for sale to the consumer. These are designed to ensure the safety of the end user of the product. Some examples of routine tests are the dielectric withstand test, the ground continuity test, functional run tests, and also depending on the type of product, additional tests may be specified as routine tests by the manufacturer and the safety agency to guarantee acceptable level of compliance with the safety standard. Okay, so now that we know type tests and routine tests, we're going to jump into our first electrical safety test, which is a ground continuity test. As the name implies, a ground continuity test basically is used to verify that a device or a product's safety ground connections has been made properly, and it is a continuous ground connection and a permanent ground connection. We all know that grounding electrical equipment provides a second line of defense against electric shock over and above the basic insulation of a product. And this grounding of the metal enclosures or exposed dead metal on the equipment also establishes a common ground or earth reference between multiple pieces of equipment which may be in close proximity to each other. Now, ground continuity test is normally required as a 100% production line test on electrical equipment to verify that there's continuity in the ground circuit of the device. For example, when an insulation of a product develops a fault between the line circuit and the exposed metal parts, the ground conductor provides a path for the dangerous fault currents to return to the system ground at the supply source of the current. Now, if the ground circuit is of a low enough impedance, the current will circulate through the ground conductor of the equipment, enabling the circuit breakers or fuses to open. By grounding the exposed metal parts, all normal leakage current is basically safely routed to ground and does not flow through the people who touch the product. Now, ground continuity test is a low voltage AC or DC signal applied from the chassis of the product to the ground pin. It is typically performed at a current under 1 amp to check that the ground connection is continuous and permanent. Now, we all know that this will only work if the user does not defeat the safety ground of a product. We know that sometimes, it often happens that the user defeats the safety grounds by removing the ground prong from a plug or by using an ungrounded 3-to-2 prong adapter. Now, because these practices are so common, products with 3-pronged line cords are still required to pass a dielectric voltage withstand test, just as an ungrounded Class 2 products, but the integrity of the ground circuit is what protects the operator if a fault should occur in the insulation of a Class 1 product. Also, that the ground continuity test does have its shortcomings. For example, the ground connection to a product should be rated to handle its nominal input current in case a fault occurs and the line voltage becomes present on the product's metal enclosures. Now, some testers equipped with ground continuity function only give an indication if continuity is present. Therefore, the test operator has no way of knowing that the impedance or strength of the ground connection. A ground continuity test could very well pass a product that has only one strand of wire connecting its chassis to the ground. But if a fault were to occur, this connection may not be capable of handling the input current to the product, and it could create an open ground condition and a shock hazard. So for this reason, many electrical product manufacturers have been turning to the ground bond test as a more thorough alternative to the ground continuity test, which is the next test that we're going to get into. The ground bond test. Well, the ground bond test or the ground impedance test is used to determine whether the safety ground connection of a product can adequately handle the fault current resulting from a dielectric breakdown. It basically verifies the integrity of the ground connection between the exposed metal and ground wire of the power cord. How is it run? High current is injected into the ground pin of the product's power cord, which flows through the chassis of the product, and the tester determines if the safety ground wire is capable of handling excessive current flow in case a fault occurs and the product's insulation fails. Here's a basic circuit for ground bond and also ground continuity test. If you can see here, on the left side we have the tester, the ground bond tester, and on the right side is the product with a power cord being plugged in, and high current will be applied to the ground pin, and the measurement is made by a Kelvin method, and the result of a ground bond test is in ohms. It gives us a measure of how good the ground conductor of a product is, and if it's capable of handling any fault currents to ground, hence protecting the user. Here's another diagram for ground bond test in a fail mode. This is showing that the ground bond test has detected that the ground of a product is not good enough for handling any fault currents. Here's another quick picture of a handheld tool being tested for ground bond test. In the picture we have our high amp 3 from Associated Research, which is our dedicated ground bond 40 amp ground bond tester. So quickly going back to the ground continuity test, just a comparison between ground continuity and ground bond test. Well, ground continuity test verifies the existence of a ground connection. The ground bond test verifies the integrity of a ground connection. Ground continuity test is a quick test to set up and easy to perform, and it's usually used as an extra feature during the high-pot test, whereas the ground bond test provides more valuable safety information about the device being tested. Let's see. Now, by simulating a failure condition and circulating excessive current through a product's ground connection, the ground bond test helps to verify that the integrity of the ground connection to earth is solid and good enough. Now, should a product's insulation fail, this low impedance ground connection is essential to ensure that the lethal fault current will flow to the ground and not to a person that comes into contact with the device's metal enclosure. Now, many safety standards are requiring a ground bond test to be performed by manufacturers as a 100% production line test, in addition to a type test. For example, and also the test parameters for a ground bond test, they can vary from standard to standard. Manufacturers must consult the safety standard that they are trying to comply with before setting any test parameters. This is very important to know, because before setting any test parameters on the product, the manufacturer must have all the information for setting these parameters, and for that they need to consult the standards that they're trying to comply with. For example, UL 60950 for IT equipment calls out for the test current to be twice the fuse rating of the product or twice the current rating of the circuit under test. The test voltage is not to exceed 12 volts, and the duration of the test to be 120 seconds, 2 minutes. Ground mount tests can be run in AC or DC mode based on the product and the safety standard, whatever the safety standard is calling out for. Okay, so next we're going to jump into the dielectric withstand test, which is also referred to as the high-pot test. This is one of the most common electrical safety tests, and it is performed usually by the product manufacturers. This test is designed to basically stress the product's insulation far beyond what it would encounter during normal use, with the assumption that if the insulation can withstand a much higher voltage for a given period of time, it should be able to function adequately at its normal voltage level for the life of the product. And that's why we have the term voltage withstand test. This test is a deliberate application of high voltage potential between the mains input and any exposed dead metal on the product. The resulting leakage due to the application of this high voltage is measured to determine whether a product's insulation is able to withstand the high voltage without breaking down. This test verifies that the insulation of a product is capable of protecting the user from any leakage current as a result of an electrical fault within the product. Here's a little circuit for showing us the dielectric withstand test, how it's set up and how it's run. As you can see, the high voltage is applied to the mains input of the product under test, and the resulting leakage current is measured on the chassis of the product. Now, in addition to overstressing the insulation, this test is also performed to detect material and workmanship defects, and most importantly, small gap spacing between current carrying conductors and earth ground. When a product is operated under normal conditions, environmental factors such as humidity, dirt, vibration, shock, and contaminants can close these small gaps and allow current to flow, which can create a shock hazard if the defects are not corrected at the factory. No other tests can uncover this type of defect as well as the dielectric voltage withstand test. Now, most most agencies, safety agencies, require the dielectric voltage withstand test to verify that a product's design meets their standard. But it is also required as a 100% routine production line test for every product manufactured. Here's another diagram showing how the dielectric voltage withstand test is run. As you can see, the green trace is what's showing us the high voltage being applied to the mains input, and again, the resulting leakage being measured off of the chassis of the product under test. Here's a failure condition being simulated. This is where it's showing that the insulation has failed, and a lot of leakage current is flowing on the surface of the chassis of the DUT, which again can pose a shock hazard for the users. Here's another picture of a very basic device, a fan in this case, being connected to a high-pot tester. So leakage current, as we all know, is present in every product to some degree. Leakage current becomes a problem when it reaches excessive levels due to dielectric breakdown. The result of a high-power test or a dielectric withstand test is usually displayed in milliamps or microamps depending on the test type. Now this test is performed on both class 1 and class 2 products. This test can also be performed in both AC and DC mode, again based on the safety standard. The test voltage and the trip settings must be specified by the manufacturer in accordance with the standard, the safety standard they're trying to comply with. Most safety standards specify the test voltage to be calculated using the following formula, which is 2 times or twice the product's rated voltage plus 1,000 volts. So for example, if your product is rated at 120 volts, your high-power test voltage that you're going to set would be twice, 2 times 120, which is 240 plus 1,000, so 1,240 volts will be your high-power test voltage. Now again, this is a basic rule of thumb for setting high-power test voltage, but again, one should always refer to the standards that they're trying to comply with to get the correct test parameters for this test. Next, we're going to cover the insulation resistance test. And before we get into the insulation resistance test, I would like to remind you all once again that this webinar is being recorded, and feel free to use our Q&A facility to ask any questions through our chat line. We have Nick Pietrowski, who is available to answer any questions that you may have on our chat line. Also, the test that we're going to cover in this webinar, in our upcoming webinars, we're going to be going into a lot more details about these tests. So this is just you can call it an introduction to the electrical safety test types. We're going to be covering each of these tests in a lot more detail in the upcoming webinars. So I would highly encourage you all to keep joining us for our upcoming webinars. Okay, insulation resistance test. This test is basically used to provide the manufacturers of a product with a quantifiable value for the resistance of their product's insulation. The insulation resistance test is very similar to a DC dielectric withstand test. It stresses the same insulation on product as the high-power test. Hence, this test is the least commonly specified electrical safety test. The insulation resistance test applies a DC voltage across the insulation of a product and measures the corresponding leakage current, which is used to calculate the resistance of the insulation. Although most insulation resistance testers have a variable output voltage, this test, according to the standards, is usually specified at 500 to 1,000 volts. The result of this test is displayed in is a resistance measurement, and it is most commonly performed on serviced and repaired units to verify the integrity of the product. Now, based on the result of this test, high insulation resistance value is what indicates a good insulation. Although this test is related to a high-power test, the insulation resistance test provides more information about the device being tested, which can be useful in certain applications. And furthermore, the IR test, or the insulation resistance test, is sometimes called out by the safety agencies to be performed subsequent to a high-power test in order to make sure that the product's insulation was not damaged as a result of the high voltage being applied to it. Like other electrical safety tests, the test parameters of an IR test should also be based upon the standard that the manufacturer is trying to comply with. Here's an example from the EN 60204-1, which is the standard for safety of machinery, which specifies a 500-volt DC test between the power circuit conductors and protective bonding circuit. And also the resistance shall not be less than 1 mega ohm. In the picture below in the bottom you can see a basic transformer being tested for insulation resistance. Also, insulation resistance tests are always performed using a DC voltage. This is due to the real and the reactive current components produced as a result of the device's dielectric or the insulation. Applying a DC voltage to a device basically negates the reactive or the imaginary current component caused by the product's capacitance and allows the insulation resistance test to perform a true real current measurement. Okay, let's next we're going to be covering the line leakage test. This test is most commonly performed on and used by medical equipment manufacturers. What differentiates this test with the other test types that we covered is that this test is run on products while the product is running or functioning as normal. So line leakage test is performed on electrical products to measure the leakage current which could flow through a person while the product is operating. A measuring device is used to simulate the impedance of the human body under different conditions depending upon the application of the product. This test can be run under both normal and single fault conditions and reverse polarity on the input line power at 100%, 110% of rated input. Again, this is most commonly performed on medical equipment. Here's a typical circuit for a line leakage test, and you can see the different switches here, S1, S2, and S3, and also the MD, the measuring device, which is based on the standard that the product is trying to comply with. These switches, S1, S2, and S3, are what can set up, simulate different fault conditions during this test. Now again, the measuring device can vary from standard to standard. Here's an example of a measuring device for EN 60601, which is the standard for medical electrical equipment. As you can see, the measuring device consisting of basically resistors and capacitors and simulating human body impedance. Once again, we will have, in our upcoming webinars, we will cover all these tests in a lot more detail, especially the line leakage test for medical device testing. Next, we're going to get into giving you guys some tips on how to find the right tester. Associated Research has a complete line of electrical safety testers that are capable of performing the most common electrical safety tests that we just went over in this webinar. From stand-alone testers to all-in-one test safety compliance analyzers and complete MET test systems. We have testers for US and the international market with the CE listing. We do have a custom software called the AutoWare software, which is compatible with most of our units, our testers, and we do manufacture scanning matrices for multi-point testing, and combine all these things together, we can it allows the user to run fully automated multi-point testing. We can also come up with custom built systems based on your specific test needs. We do have a variety of accessories and protective equipment to further make your testing simple, safe, and efficient. And most of our testers come with safety features such as the smart GFI for maximum operator protection. Here's an example of one of our testers, which is a complete electrical safety compliance analyzer called the Omnia 2 series. This tester is capable of performing the dielectric withstand test, the ground bond, the ground continuity, the insulation resistance, and the functional tests such as the line leakage test. We also have custom software available for full automation for the Omnia 2, along with the capability to perform multi-point testing using scanners. For more information on these, feel free to visit our website asresearch.com, and feel free to get in touch with us, and we will be more than happy to assist you in finding the right tester. We also have standalone testers for performing individual tests. In some of the previous pictures where I showed some examples of ground device being connected to a ground bond tester, we have testers that can just perform ground bond tests at different current levels. We have testers that can just perform the high pot test, the insulation resistance test, and just the line leakage test. And again, we have a complete of 4-in-1 or 5-in-1 testers as well, which are complete electrical safety compliance analyzers. Now, in order to find the right tester, a tester that fully fits your needs, the first and foremost thing is to understand and know and have all the information regarding the test details. What tests are required for your product. For that, you need to consult the safety agency or the standard that you're trying to comply with. And once you have this information available, it becomes a lot easier to find the right tester. Also, the test parameters and the trip level settings must also be available before you go on to selecting a tester, because you want to make sure that you are selecting a tester that is meeting all the needs and that is able to perform the tests at the parameters that you're expecting it to perform. We have, once again, Associated Research has excellent customer support to help customers understand their testing needs and find the tester that best fits their needs. We have on-site training available, along with a lot of detailed training material, white papers, and of course webinars such as this one. For more information, feel free to visit us on asresearch.com and call us at 1-800-858-8378, and we will be more than happy to assist you with finding the right tester and also helping you with your specific test application. Okay, next we're gonna cover and we're gonna go over some tips and tricks of things that you are not supposed to do when running electrical safety tests. Now, as we all know, electrical safety testing requires a thorough understanding of the tests being performed and the product being tested. So safe practice and proper operator training is very important to ensure that tests are conducted in a safe and efficient manner. Electrical safety tests such as the ground bond test and the dielectric withstand test are very high current and high voltage tests, and these tests pose a safety hazard to the operator performing these tests. Simple precautions it can be taken to ensure operator safety. For example, while the test is running, the operator should do not disconnect any test leads. This can be a shock hazard. This can pose a shock hazard to the operator. This can also be damaging to the tester itself or the device being tested. Again, do not connect any additional cables and leads to and from the tester when the test is running. So when the test is running, you should know which cables and which test leads should be connected. If you don't know that, do not attempt to perform the test, because that can lead to safety hazard for the operator, and it can damage the tester and the device and your product that you're trying to test. Also, we highly encourage, for those of you who already use our testers, we highly encourage you to to make full use of the manual and all the literature that's provided with the tester. Do not attempt to use the tester in environmental conditions that are beyond the specifications of the tester. We do specify a range of environmental conditions, temperatures, and humidity levels, and etc. In which our testers should be used. So we highly encouraged not to use the tester beyond these specifications. Also, do not attempt to perform tests on a product that are not meant to be performed for that product. This means if you have a product that and you're required to run, say, a particular type of test, do not try to perform any extra tests on this product. This can also prove to be harmful to the operator, and it can damage your device or product that you're trying to test. Once again, if you're not familiar with the device, do not attempt to use the test device, because if you're not familiar with the device, once again, these test devices are capable of outputting very high voltage and high current. So if you are not familiar with these devices, do not attempt to use these. Also, we do specify power input parameters for our testers. So do not attempt to power up a test device with an unknown power source or outlet. This, again, can lead to safety hazards, and also damage the tester itself or the product that you're testing. Also, do not assume anything about the functionality of a tester. Always read the manual. We have very detail-oriented manuals that you can go over, and again, if you have any questions on any application or any functionality of a tester that you already are using from Associated Research, feel free to give us a call. We have a very helpful staff of sales guys and applications who they'll be more than happy to help you guys with any questions. Another very important point is, do not attempt to defeat the protective ground on the power cord by using an extension cord without a protective conductor. Once again, when we were discussing the ground continuity and the ground bond test, we know that there's some people do try to defeat the ground of the power cord by using an extension cord without a protective conductor. Do not do this. This can lead to very serious issues, safety issues, and issues with the product being tested. Also, do not replace the power supply cord for any tester that from Associated Research with an improperly rated cord. And do not block the ventilation slits during operation. Most of our associated research testers have ventilation slits and fans to cool down the testers, because they are sometimes outputting very high voltage and currents, which can heat up the internal circuitry. So make sure you do not block these ventilations or cover these. These can lead to serious damage to the tester and also can lead to some safety concerns. Another very important point is not to perform any electrical safety tests in or around ESD areas. Now, ESD and electrical safety testing do not go together. You don't want to ground the test operator, because this can lead to harmful or fatal electric shock. Also, we highly encourage, for those of you who are already using our testers, we highly encourage you not to use any accessories that are not approved by the manufacturer, that is by Associated Research. We have a very huge list of accessories that are approved by us to be used with our testers, and we highly recommend that you use these accessories because these are approved by us, and we know these are safe to use with our testers. With that said, I think we're done covering the most of the material for today's webinar. I would now like to leave the forum open for any questions that you may have had during the webinar on anything that was presented, any test types, any specific questions. Once again, I'd like to remind you that this webinar is being recorded, and the test types that we covered in this material, we will be covering these in much more detail in the upcoming webinars. So stay with us for our 2014 series of webinars. This will help you a long way in understanding electrical safety testing, and we'll also be doing some webinars with specific applications such as medical device testing and etc. So that will be very helpful for those of you who are in that field. I would now like to leave the forum open for questions. Use our test chat facility, and in the end, I would like to thank you all for your time and patience in attending this webinar. Feel free to email Jim Kennedy if you want a copy of the presentation of the for this webinar.
Hey, Sad.
Yeah. So,
We got one that just came in here a second ago, and I thought this would be a good one to address to the group. The question is, how do you establish the amount of current used for the trigger threshold of the high pot test? So in other words, what they're wondering is, how do they set their leakage current threshold for high pot testing?
Okay. Well, we just had a question for regarding how to set the high pot current thresholds, which I guess you're talking about the high pot test high limit and the low limit. This can be done in a few different ways, but my own preferred way is to run basically a sample of products, more known good products. So let's say you run like 5 to 10 different products and measure the leakage, the nominal leakage that you're seeing out of these known good products, and based on this you can set your high and low limits. A basic rule that we use here at AR is to find that average leakage out of a sample of products, and so for the high limit, what we can do is we can set it, we can do a 25% of that value. So basically, say if your high limit is averaging out to be 2 milliamps, you're gonna for your high limit, we recommend that you set 2 milliamps plus 25% of 2 milliamps, and for the low limit, you could do 2 milliamps minus 25% of that of 2 milliamps. So that's a good way of setting your high and low current thresholds.